can see, we've got 4 parts of the chart to fill in. We have 4 different types of plate boundaries, and for each of them we are going to describe. I have already given you a picture, but you can color it in if you'd like. So what it looks like. Then we've got our evidence. That is a checkbox list. We are not going to check everything for them, but that is the list of what may or may not be at each location. And then you will locate items. That also matches with your plate tectonics map project task number 6. So go ahead and copy down your definition or your describe for what is happening at a divergent boundary. Like we did before, we wrote down that the keyword to remember for divergent is to divide. So here it says that there's 2 plates divide apart and the lava fills in the middle, making new rock. The ground crumbles and cracks some as it separates. So, by the way, the word plate, as you saw in Quizlet, it stands for a piece, like a puzzle piece, of the Earth's crust. So plates are very large. Most would be bigger than a state. Some are bigger than a continent, like the African plate is Africa plus surrounding rock in the ocean. Some can be very tiny, such as areas around Cuba. So it really varies in size, but all are very large, bigger than anything that we could walk across in one day. So 2 plates dividing, as you can see in this picture, this mostly happens in the ocean. There's very few examples of how this looks on land, but it can happen on land, such as Iceland. So if you take a look at my animation here, this blue up here is representing water. So kind of imagine that there is, let's say, a fish swimming around, sharks, whatever, swimming around here. We're in the ocean fairly deep, far away from any continent land, a long boat ride to this place. As I hit play here, you can see what's happening. Now this would be an animation very high speed. This would take thousands of years possibly to happen. One way to kind of think of this is the plates separate and move about as fast as our fingernails grow. So in about a year, it would maybe grow an inch or 2 apart from each other. So this would be very fast forwarded. Down here, this lower portion would represent the upper part of the mantle, in other words, the asthenosphere. This part here would be representing the crust, the solid brittle part of the crust, which is why they're representing some cracks here as they spread apart. That's also called the lithosphere. So we can see here that because of convection, there's hot areas in that outer core, as we know, is very hot. That causes the areas of the mantle to rise up. As that rises up, that would cause this kind of motion of this separating. So this hot area rises up here, and when it kind of hits the ceiling of the solid brittle crust, it causes that to be pulled apart and separated. That pushes it up, causing this bump, which is quite large. That is actually representing an ocean ridge, which is why the ocean is not flat in the very middle and not deep in the middle of the ocean. And then also because this is spreading apart, it's not creating a hole. Instead, this hot material from the mantle, the magma, is rising up and cooling into lava, creating new rock along this line. So what this would actually look like if we took a submarine trip down there. So this area here is more towards areas closer to the surface like Iceland, where it is not as deep. Most of these areas like these ones here, over here and here, it's actually quite deep and not very bright with sun. Areas like this where it's closer to landforms like Iceland, we can get closer to the surface and see a little more light. So as you can see, the surface would in fact look cracked. It is breaking apart, it's spreading apart. Kind of think of it like pushing apart a blanket. It's going to wrinkle up, but it's actually brittle, so it's going to crack as well. Would look pretty cool, would sound pretty cool. We have lava leaking out extremely hot into a cool ocean, so that's going to cool very quickly into new solid rock. Some of that can actually cool into chunks, and it's called pillow basalt because it forms large pillow-shaped rocks, and basalt is the common rock made by lava in the ocean. This is a very fast-forwarded version of how this would look. So if you look up at the top part here, it's saying in time in MA meaning millions of years. So starting about 180 millions of years, we can see the continents moving apart. You can recognize this continent shape over here is South America. This continent shape over here is Africa. So we'd have Europe up here and an edge of Canada here, maybe including Maine or New York in the US here, but mostly Canada. So this would be the Atlantic Ocean. Once upon a time, this proves that they were connected. We would have been able to travel from South America to Africa simply by walking. Then they cracked apart, and over the last 180 million years ago, that ocean has spread apart with this divergent boundary. So this is kind of explaining why we have that rainbow effect on our geochronology map. And this wasn't only in the Atlantic Ocean. We also saw this in a lot of the other oceans as well. So anywhere else that we see this rainbow pattern on our geochronology map would prove a divergent boundary. So let's go to our checklist here. So at that place, because as we can see from this diagram here, the Earth's crust is not very thick at that place, the earthquakes mostly occur at the top. So this place we would have shallow earthquakes. We can't check both shallow and deep, so it's only shallow. We're also going to have volcanoes, some, not very many. As you can see, if you look on your volcano map in the Atlantic Ocean where that animation was coming from, you can connect the dots a little bit. There's not very many, but there is areas of new rock forming from lava leaking out, so we can count that. There's not any land mountains because these areas occur in the ocean. There's not any island chains being made in that ocean area. There's very few islands. Not a trench either. There is, however, an ocean ridge because the mantle, the hot magma is pushing up and causing that bump. And most definitely the main piece of evidence for this plate boundary is the fact that we have new rock. If I can move my check mark. There we go. So we'd also have new rock. All right, for our next type of plate boundary, like we used the word before, crash for convergent. So go ahead and copy down the description. So how we can describe this is that convergent, notice there's two convergents here. The first one we're going to discuss is convergent with subduction. So that means that it's an area of either an ocean plate or an ocean with a continent plate. And they're crashing together and one plate goes under the other into the mantle. So subduction is the term for when one piece of land is pushed under the piece of land. So as you can notice already, these two both have a piece of the crust getting pushed into the mantle, whereas this one down here labeled without subduction does not. So that's obviously going to be our key term for what subduction means. All right, if we take a look at this animation right now, this is one representing a place where we have oceanic crust and continental crust. These two are going to crash together as I start up the animation. Notice that the oceanic crust is the one that goes under the continent crust. A reason for that is that when rock forms under the ocean, it has less oxygen present and it creates a much denser type of rock. When there's oxygen present, it creates a type of mineral called silicas, and those are often light in color, and they're also less dense. Under the ocean, we get less silica, so we end up with rocks like basalt that are much darker in color and much more dense. So since this is more dense and it's also thinner, it is going to lose the battle against the continental crust and get pushed under. Now, if you notice, once it gets pushed under, what happens here, what the artist is representing with that, is that it's inside the mantle where it's warm. That does end up melting back into magma again, and that is going to create volcanoes on the opposite side. It is not creating any volcanoes on the side that is pushed under. It's only creating volcanoes on the side that it goes under. Also, if you notice here, the ocean becomes much deeper there now. In this animation, this is representing a giant continent over here. So while this part here does not look much deeper, that in fact in reality would be very deep. Okay, obviously as this pushes, it's also going to create a lot of earthquakes. And one factor we're going to be able to find is it's not just going to be earthquakes at the surface. As it goes under, we're going to get earthquakes here. We're going to get earthquakes here, 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 and here. So this is going to be one of those places where we find red dots, yellow dots, green dots, and blue dots on our earthquake map. So one of the biggest ways to find a boundary with convergent and subduction is a place where we had multiple colors of earthquake dots. We drew that on our paper map with a blue marker. So anywhere that you have a blue marker has one of this type of boundary going on it. What this would look like in reality, if it is an ocean colliding with a continent, on the continent side, as you saw in that animation, the land rose up. That is going to cause the land to fold, to crack, and cause lots of mountains. In the ocean, it's going to cause deep areas, like Finding Nemo here as they dove into the deep, dark places. And then here, this is just an artist's picture of the crust will melt and cause volcanoes. Oftentimes, because the ocean floor has biological remains on it, like plankton and such, that can go into the mantle with the rock layer, and that causes a much more explosive volcano than we would have in places like Hawaii. So oftentimes these volcanoes are not only volcanoes, but they're actually very explosive volcanoes and can erupt quite violently. So this can happen in another way. This example is with an ocean side and another ocean side. However, notice that this ocean side has the continent closer. This eventually, if we went in a boat this direction, we would see that we would eventually hit a continent as well. But this side has a continent closer to it. So in the battle of the two ocean pieces together, the one with the closer continent is going to win because it's kind of got its big brother holding its back over here. Notice that the one that goes under, once again, we have the hot magma rising up as the plate melts. That's creating volcanoes here. However, it's not creating any land mountains because we're not on land. Instead, it's creating an island, as this says an island arc, but as we marked it on our maps, an island chain. Places like this would be like Japan, in the Caribbean Sea a lot. Anywhere that there's subduction, it's going to create long lines of islands. This picture doesn't show it very well, but right here, as one piece subducts under the other, we would also get a deep ocean trench again. So this place is easiest to find by looking for a place that has a trench. So we mark that with pink marker, next to an island chain, which we marked with orange marker. Also, we have a place that it is getting deeper and deeper. So we would have earthquakes here, earthquakes here, earthquakes here. So we're going to again get red and yellow and green and blue earthquakes. So we're going to get a rainbow color of dots again. So we mark that with blue. So like I said, we're going to have a pink marker line, an orange marker line, and from the earthquakes, a blue marker line on any spot that is like this. Okay, how this would look is there's going to be lots of islands. Those islands are going to be special because those islands are all going to be volcanic islands. They may still be active, meaning they still erupt. They also might not be active anymore. It depends if the plate is still moving very much. This place I picked here is the Aleutian Islands. That is those islands that stretch from Alaska over to Russia. Those are all formed by volcanoes. Those islands will grow bigger and bigger as the years go by, and someday could form a complete land bridge between those two continents. Again, there's a trench also, so once again, Finding Nemo would find the deep, dark trench. So I've made two lists here. We've got, so add checkboxes for yourself right there. Pause if you need to. The first check marks are going to be for where we had ocean, so O, colliding with continent, C, so OC. The second checkbox here is going to be for where we had ocean colliding with ocean. Okay, so when we had ocean and continent and ocean, both of those had the shallow and deep earthquakes. Any place with subduction is going to have a blue line on our map marking that it had all the colors of the dots for that. Always there's going to be volcanoes. There's always only going to be volcanoes on the side that is the top layer, the one that is having the other layer go under. If it's ocean continent, there's land mountains. If it's ocean, there's an island chain instead. Both of them are going to end up with a trench. Ocean ridge is not present there. Ocean ridge is only for divergent. And new rock also only for divergent. So those are the only features we're going to find. But if you find all of those features at any place on your map, that is for sure a place that is convergent with subduction. All right, continuing on to convergent without subduction. So this means two pieces of land are going to crash into each other, but neither one is going to sink under. So here it says when two continent pieces crash and both are too thick to subduct and they just smash together. So this is kind of a very simple model of this. So if you watch these, the kind of darker reddish brown and the gray are representing the continental crust. This layer down here is representing the mantle. You're going to see the convection arrows of hot and cold, rising and sinking. So this is a place where the convection currents are pushing the crust together. However, both pieces of crust in this example, we can see green grass up here, so both are continent. As they push together, notice that they not only smash upwards, but they also are smashing down. So this is why we learned that the crust can be anywhere from 5 kilometers to 70 kilometers thick. This is what would cause a 70-kilometer thick area of the crust. One of the most famous examples of a convergent boundary without subduction is India. So notice this is the country of India. This is showing that once upon a time, about 70 million years ago, India was not actually part of Asia. It was its own little continent or island floating out in the ocean just like Australia. Over the last 70 million years, we can see from this arrow, it has moved towards the Eurasian plate. We call that Eurasian because it is combined Europe and Asia. So I know that in global studies, you guys learn that Europe and Asia are separate. However, when it comes to geology and the actual land they are on, those two are one giant piece of land. So in science, we actually classify Europe and Asia as one, even though if we look in global studies, their governments, their cultures, their countries, their language, their ethnicities are very different and are separated. But as far as their geology and the rock that they're made of, they are the same one piece. So take a look, what's going to happen, you can kind of predict in your head. India is out here in the ocean and it's going to move its way towards the Eurasian plate as the 70 years or 70 million years tick by. Go ahead and take a look. So as you can tell, this is very fast. That's 70 million years flying past your eyes. As it begins to hit, it actually smashes the land. It would be smashing the land. There is rock under the ocean. So all of the rock under the ocean is getting plowed into the continent as well. And all of that is smashing up, as we know from what is located here north of India by the countries of Nepal and by China. There is the Himalaya Mountains. Those are the biggest mountain range in the world on Earth. And that is all formed by all of this landform, all of this land mass in the ocean and in the continent here being plowed and smashed up by the Indian plate moving into Eurasia over millions of years. And one proof of this is we could dig into the mountain area here and actually find fossils of oceanic organisms that had died in the ocean floor here, been fossilized there, and pushed into the mountains. So even though we'd be far from the ocean, really high up in elevation, possibly snowy and icy and frozen, in the mountain areas like Mount Everest, we could still find fossils of fish and other oceanic organisms from way back when it was over here. So how this looks, this makes the largest mountains. It makes very steep mountains. One thing we call, I've already referred to it in this slides, is that it's folded mountains. If you look at these lines here, that's what we mean in geology by folded. So when the land is pushed and shoved, it will kind of wrinkle, which we call fold. You can see this picture below here too. Also these beautiful wavy lines. Those originally would have been flat and horizontal, but with the shoving of the plates together, they have wrinkled together. Um, as you know, in this mountain range north of India is mountains such as Mount Everest, which are our highest mountains, extremely high, extremely jagged like this, all because of that convergent boundary. All right, on to our checklist. For the most part, we only have shallow earthquakes there, surprisingly. There's no subduction. Subduction is what makes the deep earthquakes. If you look very closely on the seismology map there by India, you can find a little bit of yellow, but there's really almost no green and no blue. There's a few volcanoes, just some, but there are some. Okay. There's definitely land mountains. That is the biggest identifying point for this. No island chains because we're in the continent. Even if this happened in the ocean, there's no, without subduction, there's not island chains. Without subduction, there's not a trench. We're not in the ocean. Ocean ridge is only divergent and new rock is only divergent. So the convergent boundary without subduction is not as easy to find. The earthquakes are not as obvious, and there's just a few volcanoes. The biggest identifying factor, like I said, is going to be the land mountains. That's the main thing we're going to find in those boundaries. The next type of boundary is the most difficult to find in the maps. This one is called transform. Another science name for it is also strike slip. So here it says when two plates slide side by side. So you can see that in the picture here. That's going to be the side edges of the plates as they move, kind of just grinding and sliding beside each other. So you can see from this animation, it restarts itself. So it looks like they're going back and forth. In reality, they would really only be moving one direction. But they move side by side. This would kind of occur little bit by little bit. They get stuck with friction as they slide beside each other. That's why it's called a strike slip plate, meaning that they strike, like they press against each other, and every now and then they will slip apart, causing earthquakes and causing motion on the plate. The most famous one, and one that's in the United States, is the San Andreas Fault. That fault line, as you can see by my red line here on the map, goes down a large portion of California, going through some major cities like San Francisco. Up here, okay, if you watch Full House or on Netflix Fuller House, that show is filmed in San Francisco. Actually, the house that they use in their introduction is actually very close to this plate boundary. You can't see this plate boundary in the city of San Francisco, but if you fly above it in areas more kind of down in the southern part here, you could see it look like this. So if you look in this picture here, you can actually see that crack. Now, if you were out for a hike and you're walking around, there is nothing, like you can't fall into the mantle. This is not really an opening. There's a little bit of a valley there in between the two sides, but they're pressing against each other. The two pieces of land are pressing against each other. Nothing can fall inside. If it rains, the rain's not going to like drip down into the mantle. And then most definitely, Hollywood, especially the San Andreas Fault, Hollywood loves to kind of poke fun at what would happen if the world was ending and we have this huge plate boundary and it moves and things fall into it. Pictures like this is just Hollywood, completely fake. not scientifically accurate, cannot happen. But pictures like this one down here and this one here are the truth of what it looks like. It's pretty cool to see. However, most places, like I said, San Francisco and stuff like that, I visited those places and you can drive right over it. There's streets paved over it. You don't even notice it. You can't even tell where it is except for now and then a sign that marks that you're there. And then you can just take your selfie and pretend you're there. But you can't really look at the ground and notice it unless a large earthquake happened. If a large earthquake happened, all the roads paved on top of it, the sidewalks built on top of it, the houses built on top of it would be disrupted, and then you could temporarily maybe see the crack. All right, let's go back to our checklist here. Transform boundaries are extremely hard to find. Mostly you're just going to have shallow earthquakes. Notice I've added or hills here. You mostly, the land mountains or the landforms that are formed, as you can see from those pictures, were not very big. They're hardly even mountains, they're more so hills, but sometimes you could, from flying above them, you could slightly see some of the breaking in hills that are made by it. And that's it. There's maybe a few volcanoes in some of those areas, like California. There are some volcanoes there. So there might be a few volcanoes, but we're not the ocean, so there's no island chain, no trench, no ocean ridge, no new rock. So that one will be a little more difficult to find, but I've already given you one free answer, which is California.